Welcome to tonight's video on Unit 4, Part 3, Congruent Polygons and Triangles. So the first thing to understand is definition of congruent polygons. And that means if two polygons are congruent if and only if all their corresponding parts are congruent. So here, notice these two triangles are congruent. And when you write the congruent statement, notice that the order does matter because you want to match up the corresponding parts. So for example, A here corresponds with H here because notice they have two marks. B corresponds with J because they have one mark. And C corresponds with K because they have three marks. So when you make the congruent statement that the triangles are congruent, you need to match them up according to what corresponds with what. So that is the definition of congruent polygons. And the definition of congruent polygons, when we write that as a reason, we will say corresponding parts of congruent triangles are congruent. That's what CPCTC stands for, corresponding parts of congruent triangles are congruent. Or if it's just a polygon in general, this is specific to triangle, but corresponding parts of congruent polygons are congruent. So you either have CPCTC if it's a triangle, or you have CPCPC if it's just a normal polygon, if it's a polygon, any other thing but a triangle. So for example here, the pictured polygons are congruent. Write a congruent statement and then identify all of the congruent corresponding parts. So if I were to say pentagon A, B, C, D, E is congruent to pentagon R. So notice A corresponds with R. Then it would have to be T, P, S, and Q because it has to correspond with the letters that it corresponds with. All right, so then the corresponding parts, well, that are congruent, you have angle A is congruent to angle R. Angle B is congruent to angle T. Angle C is congruent to angle P. Angle D is congruent to angle S. And angle E is congruent to angle Q. As far as the sides go, AB would be congruent to RT. BC would be congruent to TP. CD would be congruent to PS. Then DE would be congruent to SQ, and EA would be congruent to QR. All right, so now if you look at the next thing, it says the support beams on the fence form congruent triangles. In the figure, congruent triangle ABC is congruent to triangle DEF. State all congruent parts. So if you look at the way it's lettered, so that means angle A would be congruent to angle D. Angle B would be congruent to angle E. And angle C would be congruent to angle F. As far as sides go, you have AB congruent to DE. BC is congruent to EF. And then we have AC is congruent to DF. So those sides. And you can get that just by the way it's written. So in the diagram, it says here that triangle ITP is congruent to triangle NGO. So that means that IT, where'd it go? There. That IT is congruent to NG. So that means x minus 2y equals 7.5. And it also means that IP is congruent to NO. And it also means, the only other thing we know is the angle here. So it means angle O is congruent to angle P. So that means 6y minus 14 equals 40. So to find y first, we add 14. So we get 6y equals 54. So y equals 9 when we divide by 6. Then we can substitute that 9 in. So x minus 2 times 9 equals 7.5. So x minus 18 equals 7.5. We add 18 to both sides, and x equals 25.5. So there's your two x and y. All right, so on the next page, it has a similar thing where it says triangle FHG is congruent to HFG. Find x and y. So in HFG, 6x minus 8 corresponds, because f is second, to h. So 6x plus 8 is equal to 35. And then fj is equal to hg, so 2y minus 3 is equal to 2.5. So here, you get 6x equals 27. So when you divide by 6, you get x equals 4.5. And then here you add 3. So 2y equals 5.5 divided by 2, and you get y equals 2.75. All right, so the next thing is what's called the third angles theorem. And that means if you know two angles of one triangle are congruent to two angles of a second. For example, let's say we know C and K are equal. Let's say they're both 50. And then B and J here are equal, and let's say these are 60. Well, you automatically know if two angles of one triangle are congruent to two angles of the other, that the third angles have to be congruent, because notice there's only 70 degrees left over, as well as 70 here. So that's what this is saying. The third angles theorem is saying if you know two angles of one triangle are congruent to two angles of another, then the third angles are congruent as well. That's the third angles theorem. So here it says a drawing of a tower's roof is composed of congruent triangles all converging at a point at the top. If IJK is equal to, so IJK is right here, is equal to angle IKJ, so right here, and IJK is equal to 72, then it says find the measure of angle GIH, which is right here. Well, if we know that they're congruent triangles, then we know that this angle I here would have to be the same as this angle right here. And since these are both 72, to find out what the measure of angle JIH is, we would take 180 minus 72 plus 72, so 180 minus 144, and that would give us 36 degrees. And that's what the measure of that angle would be. And that's what the measure of this angle would be, since these are congruent triangles. All right, the next one, a drawing of a tile, consists of triangles, rectangles, and squares, rectangle squares, and a circle, if triangle KLM, so here's KLM over here, is congruent to triangle NJL right here, and triangle KLM is also, angle KLM is equal to angle KML, and they're both 47.5. It wants to find the measure of this angle here and know it's going to be the same as this angle here because the triangles are congruent. So once again, the measure of angle LNJ is equal to 180 minus 47.5 plus 47.5. It's 180 minus 95, and it's equal to 85 degrees. All right, next, the picture triangles are congruent. Write a congruent statement that identify all corresponding parts. So why don't you go ahead and try that on your own, and then we'll go over the answer. All right, so there's different ways you could order them, but the ones have to match up. So I did triangle LMN is congruent to triangle RTS, and so then the corresponding parts that would match up. And the reason, the justification, is the CPCTC corresponding parts of congruent triangles are congruent. All right, so then it says these two triangles are congruent, find x. So since we know these two sides are congruent, so 6x plus 5 equals 9x minus 4. And then divide by 3, so you get x equals 3. And then for y, since these two angles A and D are equal, you get 12y plus 3 equals 9y plus 18. So you subtract 3 and subtract the 9y. So you get 3y equals 15, divide by 3 to get y equals 5. Except you're trying to find the measure of angle A, so the measure of angle A is equal to 12 times 5 plus 3, so it's equal to 63 degrees. All right, so that concludes our video on corresponding parts of congruent triangles. So part 4 coming soon.